Good, good, good. So we have coordinate integer, and what's interesting with momentum, you can completely transfer it. So the question is, what momentum does integer have? Well, his p-value is just a product of his mass and velocity, right? So 300 times 20 is?
600, 6,000.
Is 6,000 what? kg, km over hr, right? So what's his p-value?
8,000.
So it's going to be 8,000 kg, km over hr, right? So the trick is, when you have a collision, momentum is actually transferred. All right, now before, they collided and stuck together. This time, they're colliding and bouncing off. All right? And so they're actually transferring the momentum from one to the other. Oops. The question is, if we know the momentum that's going to be transferred, how do we figure out velocity? Well, if we know that P equals mv, then B must equal what?
P over M.
P over M. So here we know that V equals P over M, and we know that its new momentum that's being transferred is going to be 6,000, right?
Yes.
6,000 kilograms, kilometers over hours, right? And what's its mass? 200. 200 kilograms. So that factors out, what's 6,000 divided by 200? 30, right? So 30 is the new velocity, which is
30 kilograms per hour.
km per hour. So this one here,
30 kilograms per hour. That's how much you...
this one here, it's going to be 8,000 divided by 300. What's 8,000 divided by 300?
A bigger number. No, a smaller number.
It will be 40. It will also be 30.
30? 8,000 divided by 300?
No. Whoops. 8,000 divided by 30.
What's 80 divided by 30?
80 divided by 30 is
8
About 23, right?
Yes.
So 23 kilometers per hour. Now, here's the question. If we have a complete transfer of momentum, we're not losing anything in the process to any other thing, whether it's heat, light, sound, but it's complete transfer, does it make sense that Gordon, with 200 kilograms and 40 miles per hour, is now going 30, and Andrew, with 300 kilograms and 20, is now going 23? Yes?
Yes, it does.
Why?
Because Indy had more mass, so it takes more energy for him to get moving faster.
Indeed.
So the momentum is the same, but the velocity is different.
Momentum is the same, but velocity is going to change. So, here's the question. If you had a choice of being in this vehicle, going slowly, versus this vehicle, going fast, which would you choose to be in? If they're going to head-on collision. Why the big one?
Because they are going much faster.
Who's going faster?
The smaller one.
Small one's going much faster. Why would you want to be in the big one?
It has less mass, and so
Because
if
of
you get one
momentum.
really
I
big
personally would rather be in the one that I'm in, because that would be weird. I would also
It's because the
Exactly.
momentum
So-
of the big truck is a lot
Just
bigger
makes
than
sense.
the small one. It's way faster.
Yes. Good. So, hey folks, it's really hard to get up fast enough to equal the momentum of a big truck moving slowly. So what you'll find is, when you have a collision like this, is that this truck keeps on moving in the same direction, albeit slower. So the little car slows it down, but this little car not only hits the truck, but starts going backwards. And that's when you have impulse. And you do not want impulse. You'd much rather just hit a wall and stay there as opposed to hitting a wall and bouncing off. Because that's a big change in velocity. Alright? So, momentum kind of explains that a little bit. Questions here?
Don't like big trucks and like cars to keep their engines in the front, so when like the two engines, so they don't want to push brake.
No, the reasons the engines are there is just because of the way that the car is made. It's easier to do front wheel drive and that sort of thing. Now, the engine will take a lot of the punishment, but cars are made to fold up and take all that force as opposed to actually hit and keep moving. Like an accordion. If your car will accordion, it ruins your car, but it saves you because it absorbs all that force. So it's something to bear in mind when doing, say, a rotor egg drop. Mm-hmm. You want it to accordion as opposed to being solid and hit.
But we couldn't do that because you can't have anything beneath the gun.
Right. Mm-hmm.